Okay, so today we're going to be looking at logarithms, all right? Now, we've looked at exponentials before. Okay, so exponentials. You've looked at laws, they're sometimes called indices or powers. Okay, so they're sometimes called indices or powers. It's basically when you've got stuff like this going on. So if you've got like 3 to the power of 2 equals 9, that is all an example of an exponential. In other words, you've got a power going on up there. And we've looked at like laws of indices as well, and we've just used the laws of indices in the last sort of examples which we went through. So what we're going to look at today is something called a logarithm. Okay. Now, it's important to note, the reason why I started off with these examples of exponentials, like using laws of indices, using power laws to solve equations, is because these two things are kind of related to each other. Now, I'm not going to spend a lot of time going through how they're related. Reason being is because this week I've put up an asynchronous hour on the VLE, which is talking through this very idea. Okay, so if you want to really go into detail about why this, why these two things are related, I've done that this week for an hour. Okay, so feel free to go away and watch that. All right, but the reason why logarithms are related to exponentials, what we're interested in with exponentials is what the number is. Okay, so in other words, if I take some base, so I'll write this in. So this number down here, in this case the 3, is the base. Okay, this thing up here we would call either the exponent, the index, or the power. I'll call it the power. Okay, but index and exponent are also fine names for them. And then this number over here, well, I guess it's just the number. Okay, now in the asynchronous hour this week, in the pre-recorded lecture, I've kind of gone through and said, well, we could almost imagine that thing up there is time. It's how long you've been growing for. This is your growth rate. In other words, you're multiplying by 3 for every time period. And that's like your size of your population. Okay, but if you break it down, if you take it out of context, strip all the context away, you'll effectively be left with 3 to the power of 2 equals 9. An exponential is all interested in what number we get out at the end. Okay, once we apply some number and raise it to some power. Okay. By the way, are you happy that an exponential is effectively a shortcut? Okay, if I write something like this down, so 5 plus 5 plus 5, okay, what would the shortcut of this be? I wouldn't write down 5 plus 5 plus 5. How else could I write it? How many 5? Yes, absolutely. Sorry, I interrupted you there. Yes, because you've got 5 being added to itself 3 times. So multiplication is kind of a shortcut for repeated addition. Okay? If I wrote this down, how would I write that as a shortcut?
5 to the power of 2.
Excellent, well done. So yeah, this is a subtle point, but it is a point which is worth making nonetheless. Okay, we've already got a shortcut for repeated addition. It's multiplication. This power notation, exponentials, index, powers, whatever you want to call them, it's a shortcut for repeated multiplication. Okay, repeated addition is multiplication. Repeated multiplication are the powers. Okay, so it's just a shortcut. So it's a shorter way of writing it. Okay. Okay, good. So where do logarithms fit in with this story? Okay. Well, logarithms are looking at this from another perspective. So exponentials are looking at it from the perspective of what number do you get out when you take the base and raise it to that power. So you multiply the base that many times by itself that many times. An logarithm looks at it from the perspective of what's the power. Okay, so an exponential looks at it from the perspective of the power. And the way which we write it in logarithm format, so I take this thing up here, the way that we write it is the power, that's what I'm after, okay? So the power is equal to, well, it's a logarithm, so I'm going to write log for short, L-O-G, okay? I need the base, I need you to tell me what I'm multiplying by every time. So the base kind of sticks down there, and then the number, the 9, goes here, okay? So in other words, let's just see where everything is again. This is the base. This is our number, which was here before. But the whole idea of a logarithm is that it looks at it from the perspective of the power. Okay, so it's just another way of looking at this thing. It's just rewriting it in a different way. Okay. Now, okay, so we've got a way of making the power the subject. We've got a way of making the number the subject. What if we wanted to make the base the subject? Do you know how we could do that? So in other words, I wanted to write 3 equals. I wanted that to be the subject of the formula. How could I rewrite this so that the base is the subject?
Is it log 2?
It's not. So it's not logarithms at all. If I wrote down 3 squared equals 9, but I wanted to find out, well, something to do with the 9 and the 2 would make me 3. If I said something to the power of 2 equals 9, how would you work out what that something would be?
Is it now divided?
Not divided. It would be the square root. You happy with that? Now usually we would put the root, the power, down here. If we don't put it there, it's just assumed to be 2. Okay? Have you seen that before? Yeah. So I will put the 2 in just for sake of completeness. So in that case, that's the power, and this thing under here is the number. All right, so in other words, we have kind of different ways. In fact, let me write my number around the other way so it makes it a little bit clearer. So yeah, there we go. So that there will be my number. So in other words, we have 3 different ways of arranging this particular setup, this particular equation, right? If you want to look at it so the number is the subject, then you just write it as an exponential. If you wanted to write it so the power is the subject, you'd write it as a logarithm. If you wanted to write it so the base is the subject, you would write it as a root. Okay? So there's 3 things going on here, number, base, and power. And you can rewrite these things in different forms so that each element is the subject. Okay?